Large metal bars are driven into the ground using a heavy falling object. The object strikes the bar at a speed of 6 meters per second. It comes to rest on the bar without bouncing. As a result of the collision, the bar is driven into the ground to a depth of 0.75 meters. Part A. Determine the speed of the bar immediately after the object strikes it. Okay, we know that in every collision, we can use the principle of conservation of momentum. The total momentum of the system before the collision is just the momentum of the falling object, which is m1v1. After the collision, it strikes the bar and they join together and make a mass of m1 plus m2 with a common velocity of v. This is the total momentum of the system after the collision. If we put them equal and substitute the values, we will get v to be 5 meters per second. This is the velocity of the system immediately after the collision. Part B. Determine the average frictional force exerted by the ground on the bar. Okay, suppose that this is the system just immediately after the collision. It has the velocity of 5 meters per second. So it comes to rest and no velocity. Velocity is 0 here. It digs into the ground and comes to rest. Here we have the total kinetic energy and the potential energy as the mechanical energy of the system. But when it comes to rest and travels for 0.75 meters, it doesn't have any mechanical energy because it has lost its altitude and also its velocity. So the total mechanical energy is converted to heat. But what is the heat? Heat is exactly the work done by the friction. If the friction is F, the friction force, so F times X or delta X is the work done by the friction, which is the produced heat. X is exactly 0.75 meters. Also, we can take it to be H. Okay, so based on the conservation of energy, the total kinetic and the potential energy of the system before it digs into the ground will be this, the left side of the equation. The right side is Q, the produced heat, which is F times H. H is the distance traveled by the system to come to rest. So we can substitute the values, and here the frictional force is something we are looking for. If we solve the equation, we can find the frictional force to be 64 times 10 to 3 newtons. Pay attention, the velocity of the system exactly before it digs into the ground has been taken to be 5. So if we raise it to the power of 2, we will get 25.